Okay, so this is 1.6. In 1.6, we're talking about the midpoint and distance formulas, or the midpoint and distance in the coordinate plane. Same thing. The midpoint formula. The midpoint formula states that if you have 2 points, one is x1, y1, and the other one is x2, y2, the midpoint between these 2 points is going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. In other words, you add these two numbers divided by 2, that's your x coordinate. You add these two numbers divided by 2, and that's the y coordinate. Okay? So that is the midpoint formula. So let's do example 1 and see if we can use this formula to calculate the midpoints. Example number 1 says, find the coordinates of the midpoint of C and D, where C is -2, -1, and D is 4 and 2. So the midpoint between these two is going to be -2 plus 4 divided by 2. Then these two, -1 plus 2 divided by 2. That's the midpoint. So -2 plus 4 is +2. 2 divided by 2 is 1. I have -1 plus 2, which is 1 divided by 2. Okay, and that's how you would get that. Okay. Example number 2, finding the coordinates of an endpoint. Okay, so in this one, they actually give you the end point, and they give you one point, and you have to find the other point. So in this one, example number 2, they are going to give you one of the endpoints, and one of the endpoints is 4 and 3. So the A is 4 and actually it's -3. Now, I do not know what this is. This is what we're trying to find. We're trying to find this, but they give you the midpoint as what? The midpoint is going to be 2 and 2. 2 and 2. So I don't know this, so I'm going to call this x and y. Okay, so if I'm going to use the formula says that the midpoint of this is going to be 4 plus x divided by 2, these two. I'm going to add these two, which is -3 plus y, and then divided by 2. And this has to be 2 and 2. So in other words, I know this guy is going to be 2, and I know this guy is going to be 2 also. So I have 4 plus x divided by 2 is equal to 2. Okay, so I have to solve that. Now I have to solve for x. So I'm going to solve for x by multiplying these together. So I'm going to multiply 2 on both sides. So I'm going to get 4 plus x here. I can multiply this by 2 also, and that's going to be equal to 4, right? 4 here, because these two canceled out. I have 4 plus x equal to that, so x is going to be equal to 0. And over here, I have the same thing. -3 plus y divided by 2 is 2. So again, I'm going to multiply both sides by 2. This 2 and this 2 cancels out, and I'm going to get -3 plus y is equal to 2 times 2, which is 4. So if I move the 3 over, I get y is equal to 4 plus 3, 7. So my other point D is going to be 0 and 7. So the answer is 0 and 7. Okay? So that's how you would do that. Now the distance formula is a little more complicated. The distance formula states that the distance between this point and this point the distance is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that is the distance. Okay? And that is in the middle of page 44. Let's see if we can do example number 3 and use this formula. Example number 3 says, find A, B, and C, D. Okay, so let's find A, B first. A is 0 and 3. So A is 0, 3, where B is, I'm reading this off the coordinate plane. B is what? 5 and 1. So B is 5 and 1. Okay, so if I find the distance, so from here, if I want to know the distance of AB, okay, what do I get? I'm going to get the square root of x2 minus x1, 5 minus 0 squared, plus 1 minus 3 squared, right? So that's going to look like. So 5 minus 0 is 5. So I'm going to get 5 squared. 1 minus that is negative 2 squared. 5 squared is 25. Negative 2 times negative 2 is positive 4. It's a negative times a negative, so it's positive square root of 29. Okay, so that's square root of 29. That's what I get for AB. CD was C was negative 1 and plus 1. So let's move up here. C is negative 1 and 1. D is negative 3 and negative 4. Negative 3 and negative 4. So the distance equal to x2 minus x1. Negative 3 minus 1, so it becomes positive squared, plus negative 4 minus 1 squared. So what I get here, I get negative 1, negative 3 plus 1 is negative 2, negative 2 squared, negative 4 minus 1 is negative 5 squared. So what do I get here? Negative 2 times negative 2 is 4. Negative 5 times negative 5 is 25. Square root of 21. Yes, indeed, the two distances are the same. Okay, so that's how you would do example number 3. Then in the middle of page 45, there's a theorem. 1-6-1. 1-6-1 is the Pythagorean theorem. The Pythagorean theorem, if you remember correctly, works only in a right triangle. It does not work on a triangle that is not a right triangle. So if I had a triangle that looked like this, where it's a right triangle, and this is A, B, and C, and the Pythagorean theorem says that c squared is equal to a squared plus b squared. Okay, so that's the Pythagorean theorem. Again, it works only in right triangles. Okay, so let's see if we can do example number 4. Find the distances in the coordinate plane. So it says use the distance formula and the Pythagorean theorem to find the distance to the nearest tenth from A to B. Okay, also, by the way, as long as we're here, we also should say that this here is the hypotenuse. Okay, and these are the other legs. This is a leg, this is a leg. So the longest leg, the longest one is called the hypotenuse. So the hypotenuse squared is leg squared plus the other leg squared. Okay? So, let's see that if we can do example number 4. Example number 4, Okay, so we're trying to find the hypotenuse of this triangle. Okay, we can read off the two legs here. The two legs, so A is, looks like it's 5 because it goes from 2 to -3. Well, it's 2 to -2, I'm sorry, so it's 4. Then the leg B is 2 to 3, so it's 5. So in other words, this here is 3, this here is 5. I want to know what the hypotenuse is. The hypotenuse c squared is equal to a squared plus b squared, like that. 3 squared is 3 times 3. 5 squared is 5 times 5. This is 34, so the hypotenuse is going to be the square root of 34. Oh, it's 41. Where did I go wrong here? It's 4 and 5. Oh, this is 4. I'm sorry, this was 4. That was 4, so this would have been 4. So 4 squared is 16, making this 41. So the hypotenuse would have been the square root of that, so it's the square root of 41. Okay. Then we have example number 5. In example number 5, the 4 bases on a baseball field form a square with 90 feet on each side. When a player throws a ball from home plate to second base, what is the distance of the throw to the nearest 10th? So in other words, we have a baseball diamond. We have a baseball diamond that looks like this. So this is home plate, first, second base, third base, and this is 90 feet. And this here is 90 feet. And this is 90 degrees. So if we threw it from home to here, we want to find this distance here. So we want to find this guy. So in this right triangle, c squared is this leg squared plus this leg squared. So c squared is equal to 90 squared plus 90 squared. 8100, 8100, 90 times 90, right? 90 times 90, so I have 16200. So c is going to be equal to the square root of 16200. And we do not leave it there. We calculate that to be 127.3 feet. Okay, so that's how you'd work that. And that is we're done with 1.6.